going to discuss the law of cosines. We don't have a right triangle, and so we cannot use the Pythagorean theorem or the right triangle definitions of sine, cosine, and tangent. And we cannot use law of sines actually because we don't have a pair of an angle and its opposite side. So law of cosines is going to come to the rescue. Notice law of cosines starts off looking like the Pythagorean theorem. A squared plus b squared equals c squared. But then you subtract this other term, 2 times a times b cosine c. What you call the angles and the sides doesn't really matter. What's important is this side is opposite this angle. A and b are the other two sides. When you're doing a law of cosine problem like the one here, you always want to start with the largest side. You could actually accidentally get an incorrect answer farther down the road if you start with one of the shorter sides. So we're going to start with 8.5625 because that's our longest side. I plug that in for C, and then I plug the other two sides in for A and B, and we get this expression. We're trying to solve for angle C. First, subtract these two values. Don't subtract this one because it's multiplying cosine of angle C, so I can't subtract it like I can the other constants. So I subtract the two constants, I get negative 14.965. If you do multiply the 2 and the 5.125 and the 7.875, you get 80.71875, but then there was a -1 multiplying that. So I divide by the 80.71875. Again, that's this product. That gives you cosine of C. So then use your calculator in degree mode. We're working with degrees in this triangles. Find inverse cosine of 0.1854, and that will give you angle C. And let's see what our calculator has to tell us. So inverse cosine of 0.1854 gives us 79.3. So that is angle C, 79.3. Now at this point, you can use law of cosines again if you wanted to, or you can use law of sines because we now have an angle and its opposite side. So I'm going to choose to do that, and so sine of 79.3 degrees divided by 8.5625 gives us sine of one of the other two angles. I'm going to choose this angle opposite that side. You don't necessarily at this point have to go in numerical order. It's just important to start with the longest side. So sine of B will be this angle over that side, and I multiply both sides by 7.875, and that will give me some decimal. It happens to be 0.9037 if you calculate this product and quotient. That's equal to sine of B. Inverse sine of that value is 64.65 or 64.7 degrees. So that is angle B. Now to get angle C, we might as well do the simplest thing. All three angles have to add up to 180. So if I subtract 79.3 and I subtract 64.7, that will give me 36 degrees. That is angle C. So I now have all three sides and I have all three angles. That's one of the good places to use law of cosines. Another situation is when you don't have an angle and its opposite side. So in this case, I have two sides and the angle in between them. I have this side and this side, 8.5, 5.625, and the angle in between them. I do not have an opposite side and an angle, so I cannot use law of sines. I can, however, use law of cosines. So plug in the other two sides. I'm plugging in these two sides for A and B, and that gives me this calculation that's equal to C squared. And by the way, you can type that whole thing in on your calculator. You can type 8.5 squared plus 5.625 squared minus 2 times 8.5 times 5.625 cosine of 77 degrees. Again, I'm in degree mode because I'm working with a triangle, and I get 82.37, and that is equal to c squared. So the square root of that is about 9, slightly bigger than 9, but we'll round it to 9. Okay, so that's how we found length C. Length C was 9. Then I can find angles A and B by using law of sines, or I could use law of cosines. Using law of sines, I now know that sine of 77 degrees divided by 9 would equal sine of angle A over 8.5. So sine of 77 multiplied by the 8.5 in the denominator divided by 9 would equal sine of angle A. And if we use our handy dandy calculator here to number crunch that for us, I get a sine value of 0.9202. If we take inverse sine of that, I get A needs to be a 66.96 degree angle. So inverse sine of 0.9202 gives me a 66.96 degree angle. If you want to, you could say it's 67 degrees because it's pretty close to 67 degrees. So now we know angle A and we know angle C. The last angle B, we might as well find the easy route by taking 180 and subtracting 77 and subtracting 67, because all three angles have to add up to 180. And that leaves 36 degrees for angle B. So I now have all sides and all three angles. By the way, with law of cosines, you're going to use them in situations where you know there's only one triangle. Like in our last example, we knew all three sides, so you know we definitely knew there was only one triangle. Same thing here, like this is kind of fixed with both these lengths and that angle. Your triangle's kind of fixed. Law of sines, though, allows for the possibility that there might be two triangles that fit the initial information that you're given.